Good morning, students. Recipe course 3 is about coordinates, so we will talk about paper 1's coordinate. I classify it into easy one and easy polar one, okay? So we have 7 years paper, and this year it has high possibility that it will have the polar again because it's the last year. And MC, I will do it in the next video, okay? Next video about the notes. So for rotation and reflection, it will happen in the rectangular coordinate. For rotation, actually you need to remember in every quadrant what is the sign, And an easy way to remember it is every 90 degree, no matter it's anti-clockwise or clockwise, it's the same. You swap x and y. What is the meaning here? If we have an A point here, the coordinate is 3, 4, and it rotates 90 degree to here, it should be 4, 3. So first 90 degree you swap the x and y coordinate, and then you write the coordinate according to that quadrant because it's this one is anti-clockwise to the second quadrant here. So this one should be negative plus. So here 4, 3. First the number is 4 and 3, and then negative should be on the x-axis, right? X-axis. Okay. So here, let's say if it clockwise rotate 90 degree, it should comes to this quadrant. So it's 4, 3, but in this quadrant it's 4, negative 3 because y is negative here. So this one is positive for positive, this one is negative, negative. How about 180 degree? So clockwise 180 or anti-clockwise 180 is both the same, right? So if it's 180, it means 290, right? Equals to 2 times 90. So it means that 3, 4 to here is 4, 3, and then 4, 3 to here is 3, 4. So it keep the same. But how about the sign? The signs in quadrant 3 should be negative 3 and then negative 4. Okay, so when you rotate 180 degree to this one, it actually follow the side here. Okay, follow the side of that quadrant. And how about 270 degree? 270 degree actually equals to 90 degree, right? Equals to 90 degree. If it's anti-clockwise, it equals to clockwise 90 degree. Okay, next talk about reflection. For reflection, you need to see its respect to x-axis or y-axis. If it's respect to x-axis, only y will change. If it's respect to y-axis, only x will change. Let's take B as example, 5 and negative 5. And then when it reflect respect to the x-axis, so it's a mirror basically, right? You just jump this one, and then it will become 5, 5 because only y change. How it change? The sign change from negative to positive. Okay, from negative to positive. And if it respect to y-axis, then x change. So it goes to this side, and then the x coordinate change from positive to negative. So here should be negative 5, negative 5. Okay, so you can see only this one change, and the y keep the same. Okay, here's the note for rotation and reflection. Then it comes to our 2014 paper, the coordinate of Q and P. So it's given by this one. And then it tells you P rotates anti-clockwise 270 degree to P dot. And then Q is translate leftward. Okay, translate leftward. Okay, first we talk about P dot first. So it first standing here, and then anti-clockwise, we have anti-clockwise 170 actually equals to the clockwise 90 degree, right? So clockwise 90 degree is swap the x and y first, so 5 and then 3. In this quadrant it should be positive, so the answer is 5, 3. Okay, and then for Q it goes leftward. So for x-axis here, go leftward means more negative. So we minus. Okay, so 2, original 2 minus 21. Nothing happened with the y. Okay, it doesn't go up, it doesn't go down. It just keep the horizontal line here. So Q here, we have Q here. We just go to the left. So Q dot should be here. Okay, so after we minus it, we got the coordinates. Prove that PQ is perpendicular to P dot Q dot. So two lines here, basically proving perpendicular is the slope times together equals to -1. So we times their slope together. So MPQ and the slope of P dot Q dot, you just calculate it. Y minus y over x minus x. So the first point is the 5 here minus the -7. So 5 minus -7 is 5 plus 7. And then the -3 here minus the 2. -3 minus 2. And then for P dot Q dot, we have the new coordinate. Okay, so you need to use the new coordinate here. -3 minus the -7, so 3 plus 7. And then 5 minus -19, 5 plus 19. Okay, so we times together to check whether it equals to -1. Okay, you can use your calculator to help, and then it equals to -1, so that is perpendicular to each other. Okay, we will fast run other year's questions. So 2017, A and B point provided to you, and then A is rotated anti-clockwise 90 degree, and B is the reflection with respect to x-axis. So first, dealing with A transport from here to the third quadrant, so it should be negative, so 90 degree first swap it, 4, 3, and then negative. So we have A, and then B is respect to x-axis, so only the y change. Okay, B is here, and only y change, it means goes upward, and original is -9, now change the sign to +9, so we finish it. So you should able to finish it just in 1 or 2 minutes. And then B proof is perpendicular, so basically the slope times together equals to -1, so do try yourself, pause the video, try yourself, and then we will have yes, they equal to -1. 2022's paper, we have point S and T, then S is rotated anti-clockwise 90 degree, and T dot is the reflection image respect to x-axis. So my student, you have the ability to do it. Please try yourself, very easy. So S dot basically is in this quadrant. In this quadrant is positive, so 90 degree, you just switch it, and then positive, right? Positive. So you don't need to write the positive. And then this one respect to x-axis, so only y change. The y change from negative to positive. So we have this one. Okay, find the slope of S dot T dot, very easy, this one. So you just find the slope here, and then N. Now we go to the polar coordinate. So polar coordinate have y-axis, x-axis, but its coordinates first represent the length of the line, So for this one, it should be 5, and then the second one should be the degree. So you need to remember that we start from the s-axis here, okay? From here is the O here means 0 degree, and then a circle 360 degree, okay, a whole circle. And then the length here actually means this one is 1, 2, and then we have 5 circle, and here is 5, okay, here is 5. And how about this one? This one should be, we don't know how many circle it has, so let's say it's 20 something, and then the degree should be 290, okay, 290. So what is the concept in polar coordinate? The concept here is that we can always use tangent, side cosine tangent. Why? Because now you have the degree, right? And then you provide the hypotenuse to you. Every line here, you can draw it into a right angle triangle, and the angle provided to you, and then you have the hypotenuse. Okay, hypotenuse, you have it, and then you can calculate the x and y. And as I teach you, you can use the function in your calculator, which is this one. And then let's say you want to change from the rectangular coordinate 3, 5 into the polar, then how you do it in calculator? First shift, and then find this 5POL in your calculator, and then you put 3 and 5 inside. It will give you first the length of this line, and then the degree of this, okay, the degree of the. Now you want to change something in polar into rectangular, so in calculator you need to find this one, and then shift REC, put in the coordinate in polar, and then it will give you first the x equals a number. How you find the y? You need to press the button LCL, and then y. You have a y symbol in your calculator, so you need to LCL and then y. You can have another number, so it's the y coordinate, okay? So if you want to change to a rectangular, you need to press REC and then improve the polar one. If you want to change to a polar one, you need to improve the rectangular one, okay? So in DSE, it often asks for 2 types of question. One is collinear. Collinear means 180. So because you have degrees here, you basically need to find 2 point, and then they have the angle 180 here to prove they are straight line, or collinear. Okay, collinear means straight line. And or check any angle is 90 degree. Or sometimes if they give you the 2 lengths with the same length, the 2 lengths have the same length, it means that it can be an isosceles triangle. It can be an isosceles triangle, and most of the time it's isosceles triangle. You need to use the property of isosceles triangle. So let's start from the 201 Swiss paper. O is the pole, and then the polar coordinate of A and B provide to you. So be very sensitive of the length. The length here is the same. It means that they have the possibility to form isosceles triangle. Okay, so when they have the same length, when you connect the 2 points and the origin, they can form an isosceles triangle. Let L be the reflectional symmetry of triangle OAB. Okay, so if you are not sure how to do it, most of the time you need to draw it out. Most of the time for those coordinate questions, just draw it. Okay, so we first draw it. We have the X and Y, and then we point out the A and B in a relative position, and we label all the things. Now it asks you AOB. What is the relationship between them and the L? L is the reflectional symmetry of the triangle, everyone. So now we have a triangle here. Basically, you need to find out that it's isosceles. So isosceles triangle, and then we draw a symmetry axis here. It basically cut it into two identical right angle triangle. So it means that it's the angle bisector here. Why can't you say it's the median? It's also the median of this triangle, right? But now you are finding the relationship between L and the angle, not the triangle, right? And that's just this angle. So the relationship, actually, what have you learned is just the angle bisector, right? What have you learned? The relationship in locus as well as just geometry relationship. You know, angle bisector, perpendicular bisector, median, altitude, parallel line, perpendicular line. So not more than 90% of the cases is that the answer will be the 6. Okay, the answer will be the 6. Okay, so now we know it's angle bisector, so we just answer angle bisector. Find the polar coordinate of the point of intersection of L and AB. So AB is here, L is here, so we basically need to find this point. How we find this point? First, the angle and the length, right? So the length and the angle. The angle is very easy to find because you already know here is 10, and the whole thing here should be 120, right? 120. So basically, this one is 10 plus 60 here because it's isosceles, right? So here is 60. How about the length? How we find this length here? As we say in polar coordinate, what we used to do to find the length is use sine cosine tangent. Why? Because we know the hypotenuse, we know the angle, we can do the sine cosine tangent. So here we have the right angle. Where is the right angle? We want to know this one. So where is the right angle? Now for this one, you know it's two identical smaller triangle. So here should be 90 degrees. So here should be 90 degrees and here should be 60. So it's very easy to find this one because the 26 you already have it. We have the angle and the hypotenuse. Now we are finding the adjacent side. Cosine here because you are trying to find OC, right? You are trying to find OC. And then we put it in the formula. So cosine 60, the 60 here equals to 26 is definitely the hypotenuse. And then OC. C point is the point we're trying to find. OC here. Okay, so it's easy to find out using your calculator. And then the degree should be 70. Okay, the degree here should be 70. Adding up this 10 and the angle here 60, so 70. You have 2 point A and B, and then now be careful of that. You have the same length, so it means that we have high chance of isosceles triangle. And then find AOB, you try to draw it out. And then after you draw it out, the X and Y axis here, and then you label the degrees, you can find out AOB. Basically is 135 minus 75, very easy for this one. And then the parameter of triangle. So once it related to triangle, you know that it's something about the isosceles because it gives to you two sides the same, okay? What we're trying to do here is we connect them, make it into a triangle, and as you know, this one equals to this one, but you don't know AB, right? So actually, it's very hard to just use the coordinate, calculate AB, the length of AB. So it usually is the isosceles triangle, or it will be the equilateral triangle. So for this one, because here is 60, right? and then you know it's isosceles, so it means the base angle will be the same. And then you will find out that all angles have 60 degrees. It means it's an equilateral triangle, so every side equals to each other. So the parameter is simply 12 times 3. And then question C, write down the number of fold. Okay, rotational symmetry. So this one, maybe you already forget what is rotational symmetry. Basically, it's asking this shape here, and then you rotate 360 degrees. How many times it will repeat itself? How many times it will repeat itself? So most of the time it's a regular polygon. So if it have 5 sides, it will have 5 folds, 6 sides, 6 folds, 7 sides, 7 folds. Okay, so here, because it's a triangle, so it's just 3.
Okay, 2021's paper is given that you have point P and Q. And point P and Q have the same length. So you know what, once we have the same length here, and then you saw something about triangle, it probably is about the isosceles, okay? And then it is given that the distance between P and Q is 21. So it gives the distance to you already, okay? So we try to draw the graph out. Point P and Q, the degree, and the length. The length now is R. And you know between them, between the point P and Q, it should be 21 here, okay? So first is finding the angle POQ, okay? So you just use the 140 to minus 80, so it's 60 degrees. So you know that if it's 60 degrees, and this is the isosceles triangles here, the base angle equals to each other, it should be equilateral triangle, okay? So it means that here should be R, and then you know PQ equals to 21. So in this case, actually you already know this 3 side here should be 21, okay? Okay, so now it's finding out, so R is 21. Basically, you find out it's equilateral triangle, and then you have the length of PQ, and then the 3 sides equals to each other, so R equals 21. Very easy one mark here, and the parameter is giving the mark to you, okay? It's giving the mark to you, so 3 times 21 equals to 63.
So in 2024, you can see this year you have 3 points. And I think for 2025, if they still have the polar in part A, it will be harder. It should be have 3 points, and maybe it will be some triangle. Okay, this asks for collinear. First, we find the angles of POQ. Draw it out, and then you will find out POQ, this one. Okay, very similar to last field paper. It's 149 minus 59. Okay, so we have 90 degrees. So be sensitive, 90 degrees means it's a right angle triangle, or to say it's right angle here. And then B asking collinear, as we say in the notes. Collinear means one straight line. How to prove it's one straight line is proving here have 180. It's 180 degree, okay? So how? We use this 239 minus 59, and then to check whether it's 180. Yes, it's 180, so it's the straight line. They are collinear. Okay, find the parameter of PRQ. So PR, you already have it, as 144 plus 11, okay? And QR, do we have QR? You don't have QR yet, and you don't have PQ. But remember that even here, nothing looks like a right angle here, but it's the right angle. So for right angle, you can use the Pythagorean theory, okay? So you need to be aware of that, and then label it on the graph. If it's right angle, then you label it as a right angle. Okay, use the Pythagorean. You can find out QP and QR, and then add them up. You will have the parameter. So here should be 155 plus 156 plus 61. Okay, so you will have the final answer, 372.